Good evening, everybody, and welcome to this evening's event from Jesus College here at the Intellectual Forum. My name's Julian Huppert. I'm the director here, and it's a great pleasure to have you with us, whether you are here in person in this wonderful Frankopan Hall or you are joining us online from wherever in the world you are. There are still countries we have yet to get attendees from, and I hope you're trying to help. If any of you know people in a few countries, let me know, and I'll tell you which ones we're missing so far. This is a really exciting and I think quite important event. But just before I introduce our speaker, can I just welcome you also to Jesus College? Because while I know some of you know Jesus incredibly well, for some of you this may be your first time, and it does have a fascinating history. We originally set up in 1144 when a group of itinerant nuns were given a little plot of land outside the village of Cambridge by Nigel, Bishop of Ely at the time, as I'm sure you all know. In 1156, King Malcolm of Scotland gave us a lot more land and expanded the whole place. I don't really understand why the King of Scotland owned this part of the country. It looks to me like it's not Scotland, but maybe somebody will tell Nicola Sturgeon about the history, or maybe shouldn't. We then continued as a nunnery until 1496, when the Bishop of Ely at the time came to see how things were going. He said that there were only 2 nuns left. One of them was rather elderly, and the other was of ill fame, which you can interpret however you like. And so he kicked all the women out and turned it into an all-male college, something we have fixed well over 40 years ago. There have been amazing people during that time who have done a lot to change how the world is. Archbishop Cranmer was a student here. So we had some influence there. Malthus, who wrote a lot about population control, was here. Lisa Jardine, absolutely amazing scholar on everything from Renaissance English to chairing the Human Fertilization Embryology Authority, was here, and many, many others. And we continue to try to do our bit to get people to think and talk about some of the biggest issues of our time. Now, most colleges have a history of having their own breweries. If you go back hundreds of years ago, the water wasn't safe to drink, everybody made their own beer, everybody was slightly tipsy the whole time. We're actually unusual in that we're one of the few colleges that doesn't have a record of making our own beer, until we opened this West Court up in 2017, when we built a microbrewery, which we'll go to later for those who are here in person. So alcohol has been part of the tradition here for a very long time. There have been special brews. But alcohol is not exactly a harmless substance. And that brings me to the subject of tonight's talk. It's a huge pleasure to have David Nutt here. He probably needs almost no introduction, but I will give some. He is a brilliant, distinguished academic scientist, professor of neuropsychopharmacology, which has a wonderful collection of letters as well as being a hugely important topic. He's perhaps best known in some other areas for his work as chair of the Advisory Council on the Misuse of Drugs, where unfortunately slightly misunderstood that the purpose was to give the advice that the government wanted, not the advice that was actually accurate. And there was a bit of a test case there, and that's only how I first heard about Dave and his work. But he did some really beautiful studies which have influenced me personally in my interest in how you do evidence-based decision-making. Including a wonderful analysis which looked at the different types of harms of different types of drugs and allowed you to work out how much they harmed self versus how much they harm others. Really fantastic work. This was Lancet 2007-2010, I think. Really, really beautiful studies. Now, if we had a sensible system of policies, you might imagine that there was a strong correlation between how harmful things were and whether they were legal or not. You could imagine saying if it's this harmful, it's illegal. If it's not that harmful, it isn't. There's not much of a correlation at all. And that's been one of the big tensions in policy in this domain. You can tweak how much you weight different parameters a bit, but it's almost impossible to come up with weightings of harm that don't put alcohol and heroin as the top 2. You have to really try to find ways not to have those as the most harmful ones. We're not going to talk about heroin tonight, I don't think. It's not the main topic. We haven't got any heroin laid on for anybody who would like some. But alcohol and the harms from alcohol are very serious. They affect people who consume, who overconsume, but they also affect the rest of the public. And so David has been interested for quite a long time in whether we could come up with substitutes to alcohol. Other materials which would have the nice aspects of alcohol. I won't ask how many people here drink, but there's presumably a reason why we enjoy it. How can we have that without the harms? And that's been a quest for a very, very long time. And David has, finally managed to get there. And we're going to hear a lot more about that as well. So it's great to have David with us today. David's going to talk for about 45 minutes, and we'll then take questions from you here in the audience, and I think people have just about finished coming in late, or online, and I have no idea whether you're here on time or late, so great to have you with us as well. David, thank you so much. It feels like a long time ago that we first met and started campaigning together. Thank you for being here at Jesus.
Great. Can you hear me? Yeah. It's very nice to be in an audience where I'm not the oldest person. So thank you for coming, those of you who are of my generation, including you, Trevor, who I gather was a student at Jesus. I was actually a student at Downing, but in November 1969, I actually did come to Jesus because one of my best friends was an undergraduate here. And I was reflecting on it as I came up this afternoon from London. What did we actually do in those days, apart from sit around and talk about science and philosophy? But the one thing I remember vividly, this is something you probably wouldn't do now, wouldn't be allowed to do now. We were cooking crumpets on the gas fires in the rooms. I imagine you don't have gas fires anymore, do you? But in those days, you had to sleep in front of them to stay warm. There was no central heating in any of the colleges, certainly not in Downing. So I have a fond memory of Jesus, and it's nice to be asked back. I also have a fond memory of Cambridge, particularly this man, Jimmy Mitchell. He was the person who interviewed me as a schoolboy, and I guess gave me the tick that allowed me to come. And he was my tutor at Downing. And he was one of the people who discovered GABA. Now, at that time, there was an enormous discussion going on about whether the brain was an electrical machine, which had been assumed to be the case for about 50 years, or was it actually a chemical machine? And the discovery of the synapse and the communication across synapses led to people beginning to think maybe it's a chemical machine. But what are the chemicals? In those days, we knew about things like dopamine and serotonin, but we knew that they weren't the key neurotransmitters in the brain. We knew that they didn't communicate information, enough information to make the brain as efficient and sophisticated a computing machine as it was. And there was a great deal of interest in what were the real transmitters. And Jimmy was one of the people that discovered GABA. And GABA turned out to be the neurotransmitter that helped regulate activity in the brain. It calmed the brain down. And that was a major, major breakthrough. And a few years later, it became slowly apparent that the other major neurotransmitter in the brain, the one that turned the brain on, the on switch, so to speak, of the brain, was glutamate. And as I'll show you, they work in a wonderful yin-yang relationship to control pretty much everything that we do, see, think, hear, etc. I was asked just to say a little bit more about my career. I came here to do science. I turned to medicine because I wanted to do human science. And I trained as a doctor, and then I worked in the clinical pharmacology unit in Oxford to do my PhD. The important thing there, I think, is that I began to get a track record in alcohol research when I spent 2 years at NIH at the National Institute of Alcohol Abuse and Alcoholism doing research on the biochemistry and pharmacology and clinical science of alcoholism. And then I came back to Bristol University, set up a unit there. And at that point, I got invited to work for the government. And I think, as Julian has said, I had a little falling out with the Home Secretary and left Bristol in 2008, went to Imperial, largely to pursue the imaging work that was hard to do in Bristol because we didn't have the same facilities. And as a result of being sacked, I also set up a charity called Drug Science, which has been running as an alternative a source of information about drugs and drug policy to the government's own one, and is definitely much more successful and definitely better to be relied on. This is the graph that Julian referred to, the first systematic attempt to understand the harms of different drugs using multi-criteria decision analysis. But before that, on the left-hand side, you see a book, Drugs in the Future. And you can see the authors, me and Trevor, and a man called Jerry Simpson. And we were asked back in 2003 to pull together an expert group to work on what were well known to be the Foresight programs were programs that were run every year by the Department of Trade and Industry to explore how science would affect the future and how we could be prepared to benefit from advances and also potentially prepare us to deal with problems. And Trevor and I and Jerry worked for a year thinking through what the future of drugs would be in relation to the growing science. And the science ranged everything from genetics through to pharmacology through to sociology. And it was in that book. Well, actually, the report was so popular that they actually turned it into a book. Elsevier decided to publish it as a book, which is unusual for a government report. And that's the book. And it's stood the test of time. Most of our predictions have come to be shown to be correct. But one of the things we came up with in the book was the idea that perhaps we could use science to reduce the harms of drugs. And that gets us to the alcohol story, which I will take up in a minute. But I've just got to show you this picture of me being sacked there. It's a unique picture because it's the last time I wore a white coat, I think. And I was sacked for really arguing that hysteria about cannabis and other drugs that were being explored at the time, drugs like MDMA and methadone, was rather misplaced because the main and the most harmful drug, certainly in the UK, in terms of social harm was alcohol, in terms of deaths was tobacco. And I think the drug laws have long been a smokescreen to give politicians a pretense that they're doing something, but to allow them to ignore those two major harms. And you can see one of the newspapers at the time said that I warned of an alcohol time bomb, and that advice was ignored to the detriment of very many people who've suffered as a result of the fact we don't have sensible alcohol policies. And as I was sacked, one of my friends wrote to me and said, David, the trouble with you, you've never read the classics. Didn't you know that Voltaire said it's dangerous to be right when the government is wrong? And yeah, he was right. But I was right too. And this is some of the latest data we have in terms of the harms from alcohol. Alcohol is now the leading cause of death in men under the age of 50. And it will be the leading cause of death in women under the age of 50 within a few years. Actually, it's very difficult to get recent data. I'm suspicious of the failure of the later data to come out because I think people don't want to accept that alcohol now is such an enormous problem in people, young people in this country. And we should be doing something about it. We've known about the problem for decades. In fact, we've known about the problems really for a million years because alcohol has, for a very long time, been a popular drink and a part of human culture. So why has it been there? Why has alcohol played such a prominent role in human society? And there are various arguments, and we can perhaps in the questions we can talk through some of them. But I think the main one is that alcohol is the most pro-social drug. And one of the things that's really clear is that humans want to be social. But for many of us, it's quite difficult. And anxiety in social situations can disable us. And alcohol has allowed human society to be social for as long as humans have been drinking alcohol. And we use it in rituals, and we have festivals. And there are anthropologists and historians who believe that, for instance, creations like Stonehenge were built as places where people could have ritual celebrations using alcohol to bring together disparate tribes, to spread genes from different places, and to encourage people to have fun together rather than to fight. So alcohol is hugely powerful, and I don't suppose there's anyone in this room, well, be less than 10% of people in this room, who haven't found alcohol beneficial in social situations. And that's why we're all going back to the bar afterwards. Most of you, I guess, will have read this book by Hariri. And he makes the case that the change from nomadic life to agricultural life, the settling down of humans, was driven by the desire to grow wheat to make bread. And based on that, humanity then had plenty of time in between the spreading the seeds and reaping the crop to do other things like invent language and writing and art and mathematics, etc. But there is another theory, and this is Edward Slingerland's theory that actually we planted wheat to make beer, and that alcohol was so central to human evolution that we changed the whole way in which we lived our lives, and we became settlers and settled because we wanted crops to get us drunk. It's a great read if you haven't read it. There's probably a bit of truth in both, in fact. So alcohol has very many positive effects, but of course it also has a lot of problems, and there are hundreds of thousands of people in this country. Estimated up to 15% of all drinkers have problems with alcohol, and more have transient problems, but maybe up to 15% are dependent. Very few of them, less than 20%, are actually in treatment. So there's this vast reservoir of harm from alcohol, which is the reason it scored as the most harmful drug in the scale of harms that Julian mentioned. So that's the first thing to say. It's a problem, and we've known it's a problem, but as a society, we've largely done very little about it. And when governments tried to do things about it, like when the Scottish government tried to bring a minimum unit price in, it took 7 years to get it through. A governmental decision was then contested. It went to the Supreme Court in Europe, the British Supreme Court, and eventually was allowed. And that tells you the resistance to changing alcohol policy is very deeply ingrained. And of course, it's largely driven by the companies that make alcohol. But as you all know, I've already told you, alcohol is a very ancient technology. We've been using it ever since we now have any records of humans doing anything. And we've known for centuries, millennia really, how toxic alcohol can be. It's toxic with its long-term use. It's obviously the leading cause of liver damage. 80% of all liver disease is due to alcohol. It's a major cause of brain damage, both due to toxicity and to trauma. It's a major cause of cardiovascular disease and strokes, etc. And it contributes to at least 8 cancers and many other diseases. But we put up with it. We've closed our eyes to the harms of alcohol because most of us benefit from it. And I'm probably because quite a few of us didn't realize how harmful it was. And of course, acutely, alcohol is also a problem. People get sedated, they fall asleep when they're driving their cars, they get memory loss, they get aggressive, they get hangovers, they get violent. It costs twice as much, it costs £6.6 billion a year in Britain, to police drunkenness. That's twice the cost to the health service of all the alcohol problems. So it's an enormous burden on society. And it seemed to us in that foresight committee that it would probably be impossible to ameliorate or attenuate or find antidotes to all the harms of alcohol. In fact, the first 20 years of my research career, I tried to do that. I'd actually, in my PhD, actually found an antidote. I could wake up a drunk rat, stop it falling around, and I thought that was a major breakthrough. And I remember going in and talking to my supervisor, David Graham-Smith. I think, I can actually sober up a rat. We could sober up humans. And he said, what's the point of that? And I said, well, you might be able to drive home safely. you might remember what you did. You might not do it again. And he said, yeah, but it'll still rot your liver, won't it? It'll still rot your heart. In fact, people might drink more. So the antidote disappeared, and we began thinking, well, maybe if we can't reverse or protect people against the harms of alcohol, can we just do something that gives them what they want from alcohol without the harms? And that was where we began this journey to developing an alcohol alternative. And as I say, that was in the book, and it came out as an article in New Scientist there, The Demons Coming Out of Drink. And we've been working on it ever since, and it's taken a long time because it's not very easy. But we're getting there, as I'll show you. So the challenge is pretty obvious, isn't it? The challenge is we need to find a drink, and we want it to be a drink because we want people to sip it. We want people to engage in the activities that they're familiar with, which is sitting, talking to people while they drink. We want to mimic the positive effects of alcohol, but we don't want to target the other brain systems that alcohol harms. And one of the challenges with alcohol is it's a very promiscuous drug. It affects so many different pharmacological and biochemical systems. And we don't want it metabolized to something that's even more toxic, which is acetaldehyde. So where do you start? Well, you start by trying to dissect out the targets of alcohol, where the alcohol has its good effects in the brain, where it has its detrimental effects on the brain and the body. And there's a fair bit of evidence now about where alcohol does the things it does in the brain. So this is a human brain sliced through in the middle. The red arrows are bad, and the green arrows are good. So the first thing you can see, there's a lot of bad things that alcohol does in the brain, and we can predict where in the brain the alcohol does has its impact to produce things like hangover, dependence, amnesia, unsteadiness. The big black arrow is very bad because that's when you start breathing. And about 3 young people a week in Britain die of alcohol poisoning just because they drink far too much. And of course, the famous one was Amy Winehouse. But alcohol has positive effects. The positive effects, the green arrows, are sociability and relaxation, and they come from the frontal parts of the brain. And we've got a reasonable amount of evidence that the impact of alcohol on those social promoting behaviors and thoughts is due to it enhancing the effects of this inhibitory transmitter GABA. So, what is GABA? Let's learn a little bit more about GABA. So we can think about the brain as really having 2 levels of activity. The primary level is the level of the on-off switch with the billions of pyramidal cells turning each other on through the release of this neurotransmitter glutamate, which is an amino acid. It's been around in life since the beginning of life. It's part of the energy cycle of cells, but it has been adapted also to have a neurotransmitter function. And about 90% of all the neurons in the brain release glutamate. And they switch on other neurons, and so the whole network of communication across the brain is driven by glutamate. And then you have the inhibitory system, the GABA system, which are the interneurons, which regulate the activity and prevent excessive glutamatergic activity. And then all the other neurotransmitters you know and love, like dopamine, serotonin, noradrenaline, endorphins, they make up about 5% of the brain. So as I've said, glutamate is the on switch of the brain. Glutamatergic neurons turn on the next neuron. So presynaptic neuron releases glutamate, turns on the postsynaptic neuron. And everything you've heard so far has been heard through glutamate release in the brain. Everything you've remembered so far has been because you've activated glutamate receptors in your brain and laid down memories. And hopefully some of them will last. But if you have too much glutamate, you have seizures and also anxiety. And because glutamate is so dangerous in excess, whenever a glutamatergic neuron fires, it also activates a GABA interneuron. So glutamate is like the accelerator of a car, and GABA is the brake of a car. And you need the two in order to have a balanced function of a car, and you need the two to have balanced brain function. So whenever glutamate's released, GABA's released very soon after to make sure you don't have an excess of glutamatergic activity. So increasing GABA causes sedation, it calms you down, it causes muscle relaxation. but it can also cause problems like unsteadiness. So this is a very simple little schematic of how the brain works. You have these 80 billion pyramidal cells. You've got the 10 billion or so GABA interneurons keeping them in check, making sure that there's a optimal balance so that you can lay down the memories without having seizures. And the right-hand image shows you just a pyramidal cell with the apical dendrites branching out, the synapses on those. And many of those synapses are glutamatergic synapses from other pyramidal cells. Each one will connect to about 1,000 other cells. But into those synapses, you also have the GABA connections, which keep the neuron under control. Well, what's alcohol got to do with this? Well, this is essentially the bottom line. This is what alcohol does if you take too much of it. Alcohol blocks excitation in the brain. When you get to a blood alcohol level of twice the legal driving limit, about 150 milligrams percent, alcohol starts to block glutamatergic receptors. And that's why you have alcohol blackouts, because you can't lay down a memory if you've not got glutamate functioning. So it blocks excitation, but it also promotes inhibition, so it's a double whammy. And eventually, too much GABA and too little glutamate leads to a state of intoxication and can actually lead to death. And I've mentioned her already. That's what happened to Amy. So Amy Winehouse was a heroin addict. She was also an alcoholic. She was abstinent for about 6 weeks. And when she relapsed, as most addicts do, many times before they become completely abstinent, when she relapsed, it was easy for her to get a litre of vodka, which she drank, and it killed her. And it killed her, interestingly, with a blood alcohol level that wouldn't have killed her if she carried on drinking. And that's because she'd lost tolerance. But when she died, most of us assumed she died of probably, well, most of us didn't even know she was an addict. We probably presumed she'd taken something like cocaine. But in fact, it was alcohol that killed her. But we haven't really tried to use the message from her death to encourage people to think more rationally about alcohol. So GABA calms the brain, but GABA has roles in all human function. And there are particular roles we're interested in relation to social behavior, because alcohol, of course, is, as I said, it's the ultimate social drug. And we believe that a significant part of that sociability promoting effects of alcohol are due to GABA. And just here are some examples of how you can understand why a simple transmitter can have such a profound effect. You can look at it in terms of endocrine function, you can look at it in terms of tactile, haptic function, and you can look at it in terms of psychological function. So we've targeted GABA. We've decided to see if we can do in the brain what alcohol does on the GABA system in a way which is acceptable but much less harmful than alcohol. So I just want to explain a little bit about the two approaches we're taking. Our long-term vision is to produce an ingredient, which we're calling alcohol at present, which will be licensed to drinks companies so they can use it instead of alcohol. They won't brew it, they will add it to drinks which are alcohol-free. And that's an ambition that we're getting close to realizing in terms of the target molecules. There's a maybe even bigger hurdle to cross, which is the hurdle of getting it through the regulatory system. And that regulatory system in America is called GRAS, generally regarded as safe. It's an established system. America is the only country in the world that has a system which tells you what you've got to do to get something regarded as safe. We don't have regulations in this country, nor in Europe, which actually allow you to do that with any degree of certainty. So we're going to take it through an American process because at least we know what you have to do to get that. If you want to read more about the science, there's this free download of an article we wrote a year or so ago, looking at the whole concept of functional alternatives, looking at the GABA system, which I'll talk more about in a second, as a target, but also looking at other ways we can manipulate the GABA system, not necessarily through making selective new molecules, but through adapting and utilizing the enormous number of molecules which are present already in the plant kingdom that work on the GABA system. Because it turns out that GABA, because it's been around since the beginning of life, has been adapted to perform protective and communication roles in plants as well as animals. So many plants make substances which modulate the GABA system. Now, the GABA system is quite complicated. The simple dissection is between two kinds of GABA receptors, the GABA A receptor on the left and the GABA B receptor on the right. They are different kinds of receptors. The left-hand one, the GABA A receptor, is an ionotropic receptor. GABA gates a pore which spans the cell membrane, and I'll explain how that produces calming. The GABA B receptor is a metabotropic receptor, a G protein coupled receptor. I won't be talking any more about that because we haven't got time and it's too complicated. But we're focusing on the GABA A receptor because that's a receptor which is always there, opposing and balancing out the effects of glutamate. And we can image those receptors, and one of the reasons we believe that alcohol has a significant impact on GABA receptors is because they change when you drink a lot. So this is early imaging data using positron emission tomography showing that the GABA receptor system is downregulated in people who are alcohol dependent. And that explains probably why they get propensity to keep drinking more, because they're losing inhibitory control over behaviors. And it also explains why they have seizures when they stop drinking, because when alcohol disappears from their brain, they're left in a state of deficient inhibition. The brain has adapted to the excess inhibition produced by alcohol by downregulating the GABA system. And when you take away the alcohol, the system is under-functioning, so people have seizures. These GABA receptors are rather beautiful creations. This is an electron micrograph of a single receptor. It is truly staggering. So those are 5 proteins that are stuck together by electrostatic charges. And the hole in the middle is a hole. The hole in the middle is the ion channel that spans the cell membrane. And the way it works is that ion channel conducts negatively charged ions, particularly chloride ions. So in a situation where you have low levels of GABA, there's a relatively... Oh, sorry, it doesn't work. On the left-hand side, you see you've got low levels of GABA. The size of the red arrow is quite small. Chloride ions are going across the membrane in small amounts. When you increase GABA on the right-hand side, or you take alcohol, the red arrow gets bigger because more chloride ions go through the membrane. So that's what GABA does. It opens the channel, and alcohol enhances the opening of the channel. And when chloride ions get inside the neuron, for most neurons, they hyperpolarize it. They make it more stable. They make it harder for the cell to fire. And that's called inhibition, and that's calming the brain. Now, the GABA receptor is complicated because it's got 5 proteins, as I've shown you, and on those proteins there are binding sites for a whole range of different substances. There are binding sites for GABA, the neurotransmitter itself, but GABA binding sites for many other substances, including ethanol. And some of the substances which bind to that receptor work to enhance the effects of GABA. Some of them work to block the effects of GABA or moderate the effects of GABA. And some of them can mimic GABA. And this is the problem. The reason Amy died is because the level of alcohol in her brain got to a point where the alcohol opened the channel and it couldn't close. And so her respiratory center became so paralyzed she couldn't breathe, and she died. And that is that direct effect of high levels of alcohol is why it's toxic. So obviously what one wants to do if one wants to mimic the effects of GABA is to make sure that whatever you make cannot do that. So we want substances which can moderate the effects of GABA, and they're called PAMs, positive allosteric modulators. You see that on the left. They work only through enhancing GABA, but they do not have this direct effect to open the channel. So that's the primary target to find substances which moderate GABA. So if you were to take too much, you could always compensate by reducing, the brain could compensate by reducing the amount of GABA it produces. Whereas with ethanol and barbiturates, the brain cannot compensate. And the science has moved on enormously in recent years because we now have these very detailed structural models of these receptors. And this is a beautiful image showing the difference between the closed site of the channel and the open site. You can see that the left-hand image, the bottom bit, the bit that's sticking out into the cell, is very narrow. And then when GABA is added, the central pore opens up. You can see the purple pore opens up and allows the ions to travel through. So we have a really quite sophisticated understanding now of the complexity of this really complex system. And that allows us to do things like dock molecules into this receptor system in silico using data that we have from test tube models. And we can begin to explore what the requirements are to make molecules which will do what we want. Enhance GABA enough to give you relaxation, but not too much to cause excessive sedation. So that's the next target. We call those kind of molecules partial agonists. These are molecules which have a plateau effect, so that however much you take, you cannot saturate the system to a point where it's harmful. So the first level of selectivity was targeting GABA. Now we're targeting partial agonism at the GABA system. Not a trivial thing to do, quite a challenging thing to do, but we know we can do it, and we can use this kind of structure-activity modeling to help us do that. But then there's a third level of sophistication, which is to get regional sophistication in the brain. I showed you earlier on that we want to target the frontal parts of the brain where particularly social thinking and social anxiety emerges. And we don't want to target bits of the brain which are involved in dancing or playing tennis or darts or whatever. So one way we can do that is to understand the complexity of the molecular subtypes of the proteins which make up the GABA receptor. So I showed you the 5 proteins, that little bracelet with a hole in the middle. Well, those proteins come from different families. They come from alpha families, beta families, gamma families, and a couple of other families. But the main ones we're focusing on are shown here, the gamma 2, the beta 2, and the alpha 1. But there are others. There are 6 alpha proteins, 6 alpha genes, and there are 4 beta genes and some gamma genes. And they're all part of a complex evolutionary profile where a single protein has mutated and mutated and mutated to make a whole range of different related but functionally different proteins. And those come together in these pentamers to make those receptors that I showed you. And it's possible to estimate the amount of the different receptors in the brain by using immunoprecipitation. And what it turns out is that there are particular groups, pentameric groups, which are very common. So, for instance, the big blue one on the right, alpha 1, beta 2, gamma 2, that is the one in the cortex which determines whether you're awake or asleep. And if you take a sleeping pill, you turn on those receptors and go to sleep. So there's a lot of those in the brain. There's a lot of the alpha 2, beta 3 and the alpha 3, beta 2, and they're ones related to anxiety, and I'll talk more about them in a minute. And then there are less of the others, and you might say, well, do they really matter? I just want to point briefly out the alpha 5 one there, the first of the grey ones next to the red one there. You might say there are not many of those, but they actually turned out to be quite interesting for another reason, because there are more of those than there are dopamine receptors in the brain, because there's just so many GABA receptors in the brain. And all those subtypes, we presume, have specific functions, and we can show that they have differential distributions on different parts of the pyramidal cells, helping regulate those. But for the purposes of tonight, the really interesting discovery is that different parts of the brain express different receptor subtypes. This is beautiful work from Bill Wisden's group many years ago. These are rat brains. and they show very clear and profound differences in the expression of the subtypes. What we know now from this kind of work, and also studies where animals have had those receptor subtypes knocked out, that the alpha-2 and the alpha-3 subtype are the ones which reduce anxiety. The alpha-1 is the one that puts you to sleep if you take a sleeping pill. So obviously, if we're inventing a drink that potentiates GABA, we don't want to put you to sleep. We don't want to target the alpha-1. We want to target the alpha-2 and the alpha-3. And that's what we've been trying to do. It's actually extremely difficult to do, which is why there aren't any medicines out there that do that for any indication yet. But we can do it. And the other tool we've got at our disposal is PET imaging, so we can explore the distribution of these receptor subtypes once we have a selective molecule for them by tagging them with a radioactive tracer and seeing where they go. And this is a beautiful image showing a rather special subtype, the alpha-5 subtype, which is there. It's distributed on the emotive circuit in the brain. And again, we're trying to avoid that. We don't want to change people's motivation. We essentially want them to become more sociable and personable. So the big challenge of making a selective small molecule which can replace alcohol is not trivial. We've made good progress. But on the way, and I want to give credit to my partner here, and that's David Nutt. We set up a company 5-6 years ago to do this, to raise money to do this, because we weren't going to get funding, or we've never managed to get funding from government initiatives. And he said, well, why don't we make a drink from plants that have GABA-acting molecules to prove the concept? And I said, that's because I'm not a botanist. And he said, yeah, but it can't be that difficult, can it? You know. And it turned out not to be trivial. Again, it took us several years to plough through the enormous literature on plants, GABA molecules, and discover plants which are in the food chain, which we can sell in a drink as a food, so we don't have to go through regulatory testing, which is expensive and unpredictable. And we did that, and I'll show you that in a minute. So we've developed botanical drinks that prove the concept, and you're going to try them later tonight. But also, not just prove the concept, but also allow us to have a discourse. I probably wouldn't be here if we didn't have something to share with you, because it would just be a concept. But now the reality is that you can have a drink which will mimic some of the effects of alcohol, the effects that most of you want, and particularly effective in social interaction. And by doing that, we can get people interested in the greater ambition, which is to find the small molecule. And the analogy, by the way, it's called alcarel, the small molecule we're looking for. It's a bit of a pun on canderel. Canderel is for sweetness. Alcarel is for alcohol, what canderel is for sweet. Canderel gives you the sweetness from sucrose without the calories. Alcarel will give you what you want from alcohol without the harms. So, on the way, we've had some interesting allies. This is one of a number of jokes, cartoons about me in the Times. You know, they followed since I got sacked, I've become a target. I think generally seen quite favourably by cartoonists. So these are new alcoholic drinks that Professor Nutt would not invent. And you should pay particular attention to the one on the right. And this is one that I think Julian probably, unfortunately, had a lot of experience of. The Cameron's Absinthe, for special occasions only, considered too dangerous to drink unless diluted with Clegg. Unfortunately, they managed to destroy Clegg as well. But that was the joke. This is the practice. This is what we're going to share with you tonight. This is the first functional drink. It's the first drink that has been developed to target the GABA system specifically, to promote relaxation and sociability. And it's available. And we will give you some cocktails with it tonight. So that's Sentia. That's the company, Sentia Spirits. This is now in America. It arrived in America a couple of weeks ago, and if it's successful there, then it might well be that we get a significant funding to take us through to the next stage. We've also moved on from the original Sentia, which has been around for 3 years, to this second Sentia, the black. They have different flavors, they have somewhat different effects because of the different combinations of herbs we put in them. Now, there are scientists in the room, I know, there's at least one who I've published with many times. He'll say, well, prove it's GABA. And we've started to do that now. We've got a bit of funding. We've started to work with universities to provide data that will hopefully convince all of you that it isn't just a fantasy. I just want to show you a bit of data. So one of the approaches you can take is to measure the effects of drugs in the brain using a technique called EEG or MEG. And the group in Exeter University have started using Sentia to ask the question about, does it actually get in the brain? How do you know it's not all placebo? And so they've done the first EEG studies. These beautiful coloured images, by the way, are just illustrative of the different impacts that GABA drugs can have on the brain. Going from the top to the bottom, these are the different frequencies, from slow frequencies to high frequencies. And the colour coding is a measure of the power in each of those frequency bands. I won't go into any more detail, but there you've got 4 different GABA drugs going from zolpidem, a sleeping pill, to garboxidil, which is a GABA agonist, to tiagabine, which is a GABA uptake blocker, to propofol, which is another kind of GABA drug, an anesthetic, and alcohol. And you can see they're all different. And that emphasizes the fact that there are many different outputs of targeting the GABA system in different ways with different drugs. But alcohol, you can see, has an effect across quite a range of those frequencies. What does Sentia do? Well, Sentia produces changes in the brain in 2 ways. It increases the power in the red images here are alpha power, and alpha is a very important brain frequency. It's one of the frequencies which underpins a lot of your whether you're awake or asleep, whether you're conscious and attending or not. And that increase in alpha power is consistent with feeling relaxed. So that was very appealing, and it's also the effects are in parts of the brain which at least are consistent with the idea of facilitating social engagement. And there's also in other parts of the brain a reduction in gamma, and gamma are very high frequencies. So that's consistent with, I mean, again, I don't want to over-egg the cake, but it's consistent with potentially also being less stressed. And you say, okay, well, what about alcohol? Well, alcohol also produces effects in the brain, but not the same. And this is an important point. We are not trying to replace alcohol with something that is the same as alcohol, but safer. That would be impossible. What we're trying to do is replace alcohol with something that gives most people what they want from alcohol. So the fact that there is some overlap, but not complete overlap with alcohol, to us is reassuring. And then what about GABA itself? Well, we've got a studentship now down at the University of Portsmouth with Professor Swinney, who's got a model of GABA receptors in the gut. And all of you know that when you get stressed, your gut squirms. And for many people, stress is mediated through changes in gut function, like ulcers or colitis. And GABA has a huge role in the gut. And he's validated a model where you can look at the pulsatile activity of the gut, and you can change it with drugs which work on the GABA system. For instance, like alprazolam, which is a benzodiazepine anxiolytic. So we now had a studentship there, and they're exploring the effect of Sentia on the gut. And you can see on the left-hand side, you can see the gut squeezing away, as it does in all of you, to produce peristalsis, to take the food from your stomach right through to your bowel and into your rectum. And Sentia calms that down. Okay, well, what's that got to do with GABA? Well, you can reverse that effect using a blocker of the GABA system. In this case, he's using picrotoxin. So this is the first evidence that what we are doing is actually targeting GABA. And what does ethanol do? Well, ethanol does something rather similar, but not as good, in the sense that the alcohol rather dramatically reduces the magnitude of the contractions of the gut. But that effect is somewhat transient, whereas with Sentia it's much longer lasting. And that may be why alcohol isn't a very good anxiolytic in the long term, why drinking to deal with stress may have a short-term effect, but over time you may get some kind of rebound, which potentially could be even worse. So what about the synthetic molecule, the holy grail? Well, we have 3 molecular series. We've got good pharmacology targeting these principles of partial agonism, of receptor selectivity. There's a third point I haven't mentioned already, but we've also got to get the kinetics right. We've got to make a molecule which will get in the brain as fast as alcohol and get out the brain as fast as alcohol. So it's a three-dimensional challenge to make molecules that do that. It's not essentially it's tough pharmacology, but we're making good progress, and we'll be testing the final 3 molecules fairly soon, and then patent them, and then choose one and take it through toxicology, and then through the GRAS system in the States. And that's going to be massively expensive. So those of you who are rich, will you come and see me afterwards, please? So I'm going to finish now. I'll take questions and invite you afterwards to go and get your Sentia cocktails in the bar. Thank you very much.
Thank you very much, David. Some really fascinating stuff there, both the science and the concept behind it, and the history and how humans may have evolved. So we do have about 20, 25 minutes for questions, either in the room, upstairs or downstairs, or online. Just use the Q&A function on Zoom. We have somebody to start us off, so I'll do my best to keep an eye out, so do grab my eye, but we'll have the first one over there.
Thanks for a great talk. I was interested, a couple of times you sort of alluded to this is the effect that most people want from alcohol. Yes. But I was wondering how universal this was and how universal our sort of baseline experience with alcohol is. Because certainly socially, I feel like I've always known some friends or colleagues that seem to drink particularly hard and sort of not be able almost to stop after one or two.
Of course, and they're binge drinkers, and it's between about 10 and 15% of drinkers. Some people set out to get drunk; they're called undergraduates. But after that, the people who struggle with controlling their drinking, get into problems, and we've got some evidence that loss of control may be mediated through too much dopamine release by alcohol. There's some evidence that we've generated that it might be due to too much endorphin release through alcohol. At some point, it might also be that you're blocking the glutamate system and disinhibiting behavior. So there's no question that is a problem. And what we are aiming to achieve is a drink which will not push anyone in that direction, except those who really want to get drunk, and they'll be really disappointed because the partial agonist effect will mean they'll just give. You will not get that drunk on it.
So we'll have a question there, and then there's one up at the top.
Thank you for a very fascinating talk. I really enjoyed the data as well. What I wanted to ask was that different people have different tolerances to alcohol, how quickly they get drunk, and the volume of drinks per se. Yeah. So with this new Sentia cocktails, what's the volume per drink, or what's the uptake, and how quickly does it get flushed out of the system?
Yeah, so you'll find tonight, yes, it gets in quite quickly within between 5 to 10 minutes. Effects last about 30 minutes because it's washed out that quickly. In terms of sensitivity, yes, so people say, it doesn't work, and I say, how much do you normally drink? And they say, well, only a bottle of wine a day. This is not a substitute for heavy drinking. In fact, what we're trying to do is take the next generation of people who aren't yet drinking. We're trying to give them something that they can use instead of alcohol, so they don't get into the state of requiring or being able to drink so much that they come into harm. So this is not a substitute for heavy drinkers. It's something for people who want to drink less or not drink at all.
There's a question up at the top.
Thanks very much. I'm interested as to once you have these new molecules, if you will, or indeed whether you have explored patenting them for clinical applications, indeed for like treatment of anxiety or anti-seizure medications, and then a thought experiment as to whether, if they were approved in a medical use case, if that would help or hinder their approval for a social use case.
Well, it would be impossible to turn a medicine into a drink. That's a fact. So, on the other hand, we have gained a lot of intellectual knowledge about the GABA system. We have invented molecules which certainly don't fit the requirement for a drink. Could they be utilized in medicine? Of course they could. We'd have to set up another company to do that. We haven't got the time and the resources or the bandwidth. But again, if you're a chemist and you've got good contacts, we'd be happy to discuss it with you.
Can I just bring a couple of questions in from online before we move here? So one is there any risk that Sentia or Alcarel could be addictive?
There's always a risk. Some people get addicted to drinking water. That's probably psychological rather than chemical. All we can say is that our prediction is that we would be much, much less likely. And we will be doing studies to that effect. We've already set up models of hangover. So we're in the process of finding out whether it causes hangover, which it doesn't. I can't say clinically, but the experience we have, we've tens of thousands of people have been drinking Sentia now for several years. People aren't reporting hangovers. I think it's extremely unlikely, but we can validate that in standardized models we've set up. So the answer is, if it does, it's going to be much, much less likely than alcohol.
And just another one from online while we're here, from Helen Holdsworth. Will it be safe to drive under the influence of Sentia?
It's never safe to drive under the influence of anything. And certainly, just to be absolutely clear, driving, if you've got an upper respiratory tract infection, that impact on your driving is about the same as the blood alcohol level of 80 milligrams %. So you shouldn't drive if you're affected by anything. But the good thing about Sentia is that the effects wear off quite quickly. So if you're not affected, then it shouldn't affect your driving. But we certainly wouldn't recommend people using this as a way of being able to drink and drive. Yeah.
For what it's worth, I think I remember the data correctly, that if you had less than 5 hours sleep the night before, you're at about the blood alcohol level in terms of risks. And having a 2-year-old in the back is worse than the blood alcohol level. But we don't make it illegal to drive with a 2-year-old in the back. I'll take a question from up here.
Hiya. My question was just, how far do you see Sentia going? Do you think this could be sort of the beginning of the end for alcohol in a way?
Well, I don't think people will ever not want to drink some alcohols. But I think a lot of people would like an alternative, a functional alternatives. And that's really our ambition, to give people choice, because at present there is no choice. If it turns out that by making available Sentia, we can allow people who are not drinking socially to drink socially, that would be again a major advance. We would like to put the pub or the sort of the bar or this sort of social club back into British life. A lot of people are avoiding it now because they don't want alcohol, and that's what you have to get there. It would be really nice if people could socialise without having to use alcohol and not be surrounded by people who are drunk. So if we could achieve that, we would be very grateful. And there are 1 or 2 pubs now. There are at least 3 pubs in Britain which don't serve alcohol at all. They do serve this, and they serve other drinks. So if we could kind of make that at least equivalent in volume to drinking pubs, then we would have made a huge impact, because I think people will enjoy socialising without the risk of alcohol. That's our ambition.
There's a question up there.
Hi. If you already have a natural plant-based solution which does most, if not everything, what you're trying to do, why are you trying to develop a synthetic drug, essentially?
Well, for a number of reasons. The first is that we don't want to sell drinks. That's a hugely complicated thing to do. It's difficult. Scaling up, we couldn't. We're a 5-person company. Selling drinks requires hundreds of thousands of people, so that's the first problem. We're quite happy for someone else to take on the Sentia and sell it. That's the first thing. The second is that an ingredient would allow any drinks company to make any drink you like. So you'd be able to make so many different drinks. I mean, so I guess when you go and taste it tonight, some of you probably won't like the tastes. Hopefully you all like the effect. We've got two tastes. You can dilute the taste with mixers. Okay, so you can get more taste. But you could have an infinite number of tastes if you have an ingredient, because you could make any kind of mocktail you like, from beer to wine to artificial spirits, etc. So that would give you much greater versatility. And the third is sustainability. I mean, those bottles there, they're half a kilo of juice and half a kilo of glass. It's expensive, particularly to transport. If we can make a bottle of Arcorel, which will contain the equivalent of, say, 50 drinks, then it will be much more sustainable. The carbon dioxide load, transport loads will be much reduced. So there are a number of benefits in doing that.
I have a question at the front. Since you were cited, I feel you should.
I was going to ask you about whether you had a food scientist on board that would optimise the taste, which is going to be very important. Obviously, you've addressed that. But I was going to come back to a question that was asked earlier. I mean, one of the most prevalent mental health disorders that we're experiencing nowadays is anxiety. And it does strike me, that your research on the alpha-2 and alpha-3 subunits are essentially redesigning this famous class of drugs called the benzodiazepines, Librium and Valium, without their addictive memory deficit impairing properties. So would that be a more important social aim for this project, to produce an effective anxiolytic?
Well, others are doing that, but I'm open-minded. The pharmacological profile, of course, is quite different in the sense that generally, if you want to take a medicine to deal with anxiety, you'd want to take it once a day. That would be easier, Trevor, than what we're trying to do, because we want you to take every 45 minutes. So we do have molecules that fit into that category, and again, we can't do both, and I think the world needs an alcohol substitute more than it needs another anxiolytic.
Question up at the top there.
Yeah, I had a sort of couple of quick questions. If you've not got the FDA approval already, how can you sell it without that? And if you don't need it, why apply for it?
Yes, okay, so that's important, but I didn't make that clear. So Sentia, the herbs are all food approved. So we have registered, it's compliant with British food regulations, it's compliant with US FDA regulations as a foodstuff or as a food supplement. So we've done that. There are one or two countries in Europe we're not fully compliant. We're not sure we can get it into Malta yet, but that's not a target of ours. But the small molecule is different. The small molecule is a new chemical entity, so we have to go through a process of getting it approved. And we're going to the FDA because the FDA does have a set template for how you do this. Before we thought about going to the States, we went to the European Medicines Agency and looked at, well, that was when we were in Brexit, before we left Brexit, before Brexit. And we realized that they said you could do it, but we said, well, show us an example of a molecule that's been taken through this process in the last 30 years. And they said, oh, there isn't one. And that didn't fill us with a lot of comfort, because at the end, if there's no template, it comes down to a decision that's made by a committee, and if the committee, if you don't know what criteria the committee are using, so we don't think it's viable in the first instance to take the small molecule through the European regs. But the American ones are very clear, and other molecules have gone through there. So we know what to do. We just got to do it. It's expensive. It's millions of pounds. But if we meet the criteria of safety, then it will have to be approved. And then maybe, if the FDA approve it, then it'll be approved in Britain, and then maybe in Europe, and then Japan and China. Yes.
So just before we take the question up there, one question that came in from Gavin. The botanicals that you're using in Sentia, and if you have a look online or on the bottles, you'll see a long list of things. Are they already used as traditional botanicals for calming and relaxation?
They are. Many of them are. Yes. We had a search strategy, which was, is there evidence it works? That was a good place to start. And then, is there evidence it works on the GABA system? Yeah. And then the two together, that pruned quite a lot out. But yes, absolutely. Some of them have got traditional uses. Yes. And that also comforts us that there's a lot of safety there.
Yes, I think licorice is one of the leading ingredients, and it's.
That's not a leading ingredient, but it is. Yes.
So.
Firstly, I'd like to say thank you for what you're doing. I work in emergency medicine, so the effects of alcohol is something that I see frequently. One thing I wanted to know, have you engaged with any religious groups?
Yeah, we're we're in the process of determining whether it's halal, yes. And we apparently that's a decision made on a national basis, so we are exploring that, because clearly this would be of enormous interest to people, Muslims who aren't allowed to drink alcohol. So we're exploring that at present, yes.
I just wanted you to be able to share, are there any negatives to something like Sentia? It sounds like confidence in a bottle without a hangover. It doesn't give you any liver disease. It sounds wonderful.
Yeah, well, you won't. Yeah, I mean, from our perspective, what are the possible sides? Some people get headaches, occasional headaches. Some people have quite vivid dreams occasionally. But of the tens of thousands of people who've used it, we've had, and we're very receptive. People email us all the time. There's no obvious there are no major downsides. I mean, it does seem to be remarkably well tolerated, and I guess that's because we're using herbs which have already been used for sometimes for millennia, but certainly for hundreds of years. So people will get there will be some people who are allergic. So licorice, you mentioned, there are some people with hypertension. You certainly wouldn't recommend them using a lot of it if they had hypertension. But you can see what's on the bottle, and if you know there's a possibility of an interaction, then you just have to be sensible. But I will say, there is the bottle makes it explicit to drink within the current food recommended allowances. It's 100 mils a day, right? So that's compliant with our current food safety evidence.
Just to pick up on that question slightly, because there was a question from Leni. How have temperance societies and Alcoholics Anonymous responded to Sentia, or haven't they?
Yeah, it's a really interesting question. So we haven't confronted them. What we're hoping is that over time, over a few generations, they will disappear because there won't be alcoholics, because people won't be using alcohol. We've been particularly exercised by the question of what happens if you have been an alcoholic and you stop drinking and you drink Sentia. And we haven't done studies. That would be very expensive and challenging, and at some point we might have to, but we haven't as yet. But we do have a lot of people come to us and say, well, you don't know this, but I was an alcoholic and I've drunk Sentia and I've enjoyed Sentia and I haven't had cravings. I think in all the feedback we've had one person who said it did trigger craving in someone who was abstinent. And I think that's pretty reassuring, really. But, there will be some people who are vulnerable, and we probably can't ever eliminate that risk.
There's a question over here, I believe.
It's mostly been covered already by the question from up there, but I was just going to ask, in terms of longer-term side effects, you've kind of covered quite well what happens, in the immediate term, but what do you see any risks? Do you think it's fairly safe? Because I mean, at least for me personally, I would care much less about the loss of motor function whilst drinking it, but much more so about liver damage, especially if you develop a compound
Oh, the novel the synthetic. Well, I can say several things about that. That's a huge issue. That's why you have to go through safety testing, and food safety testing is pretty similar to pharmaceutical safety testing. They're almost identical in terms of the regulations and the kinds of tests you have to do, so that you cover everything, mutagenicity, cancer, tolerance, etc. We have targeted molecular scaffolds, which we know from decades of use are not allergenic, are not likely to produce immune reactions. So we can't, again, you can never say it couldn't happen, so we're fairly comfortable about that. You know, we've done our best, I think, and only time will tell. When you look at obviously the herbal drinks, I mean, these are foods that have been in the food chain for a very long time. So it's unlikely that something new is going to emerge. Okay, maybe they've not been put together in the same combination as we've done. Yeah, you can't say categorically no, but it would be surprising. But there's another twist to it, by the way, which is something that I had no clue about when we started making the herbal drink 5-6 years ago, which is the microbiome. And it turns out the microbiome likes GABA, and GABA is good for the microbiome, and good bugs benefit, the good bugs in the microbiome benefit from having GABA potentiation. So it's quite possible, and we're actually beginning to study this, that Sentia might be gut protective and maybe even gut promoting through an effect on the microbiome, and those studies are hopefully going to start fairly soon.
We're beginning to run out of time. I have 2 questions up at the top and 1 at the back, and I don't see anyone else shouting too much, so we'll have those.
Have you had any pushback from like big alcohol, breweries and distillers?
Yeah, it's interesting. So we did at the beginning. They were very sceptical and somewhat negative, but things have changed rather a lot in the last 5 years, because there's quite a lot of younger people, who are turning against alcohol, and alcohol sales are flat. In fact, if they may be falling, in some groups, there's less drinking. And the alcohol industry now, I think, may see this as their salvation rather than their death. So yes, we've been approached by drinks companies who want to own us. And we've said no, because we don't want to be owned and then stopped. But we're very happy to talk to companies who will promote the same vision, which is And when you talk to scientists in drinks companies, they know this is the future. They've just not been forced to confront it. As I say, this is the last technology of early man that hasn't been disrupted. They know it's going to happen. It's just a question of when, and hopefully it's us.
Up at the top.
Thank you for a very nice talk first. I have a couple of questions, actually. So the first one is about the data you showed about gut electrophysiology, I think it was. Alcohol versus Sentia versus normal controls. So it seemed with Sentia there was a massive drop in signal, even more so than with alcohol. And I guess that might relate to microbiome, but I was also wondering if those animals that it was tested on, like, were they observed in any...
Oh, no, this is...
Like, how did the bowels do?
No, this is all ex vivo studies at present.
Okay.
I mean, it's much... This is like screening, these are assays which are much easier to do. Eventually, we will look at whole animals. We haven't done that. Okay, but it's a great question. Your point is, should we look at the behavior of the animals as well? And that's a... Yes, yeah. If we can afford Robbins, we'll do it with him. Yes.
And then the second question is a bit unrelated to Sentia, but rather your PhD work, because you said you discovered a compound or a method to sober up animals, mice or rats. So could you elaborate on that? Or was that just out of interest?
Oh no, that's if you block the GABA system, rats sober up. Okay, so that's one of the very first pieces of evidence that alcohol works somewhere in a system which is GABA sensitive.
So we're talking about big alcohol, and we've had a question from Lacon's Brewery, who aren't, they're not Diageo, but on your website it says you can enjoy it neat or with a mixer.
Yes.
Does adding a mixer reduce the effects?
No, because the effects are determined by the quantity of herbs. So you may drink it more slowly if you drink it with a mixer, but in the end you'll get the same amount in. So I suppose, yes, if you had a long glass of it and you drank it over 4 hours, you'll get less effect than if you drink it over 4 minutes. So probably it'd be slightly less if you drink it with a lot of mixer, but not, you'll still get the same amount in eventually.
Final question from the room at the back there.
I was just wondering if you're able to say at this point if Sentia and the novel molecule are targeting the same sort of exact, did you say alpha 2, alpha 3, or
we can't say
is it just hopefully similar enough?
Yeah, yes, you're right. Certainly, what we need to do now is we need to work out exactly what's in the herbal. That's, are you a biochemist? Because doing that is extremely difficult. But we are in the process of talking to analytical chemists who can begin. We hope will begin to pull out some of the key ingredients that we've targeted, and then we can test them individually. That's the next phase. Yes, and then it'll be. I mean, just to finish, we do have a hope that maybe in herbs we will definitely find new molecules. We might be able to find new molecules which could become new medicines as well. So that's and if we can find herbs which grow naturally. I mean, so we got quite excited a couple of years ago because we found a herb that grows really wild in Indonesia, which did contain a particular molecule which we thought could actually be. It wouldn't be wonderful if people could just go and harvest the weeds and make their own alcohol alternative. But when we got the ingredient, well, we found it didn't get in the brain, unfortunately, so it's not going to work. But the principle is still there.
So, David, thank you very, very much for a really brilliant talk and a really interesting idea. You know, some of us were talking earlier about prohibition in the US and the efforts to control alcohol harms by making it illegal. This strikes me, I have to say, as a much more liberal, autonomy-enhancing approach, which doesn't say you may not, but says here is an alternative, and we'll see how many people want to take it. So thank you for sharing that vision with us, firstly.
Thank you.